Welcome to ClickMyProject.com. Welcome to ClickMyProject.com. Our project title is Energy Efficient Group Key Agreement for Wireless Network. Let's see the abstract for our project. We study a group key agreement problem where a user is only aware of his neighbors while the connectivity graph is arbitrary. So there is no centralized initialization for users. A group key agreement with these features is very suitable for social networks. So we obtain lower bounds on the round complexity for this type of protocol, which demonstrate that our constructions are round efficient. Finally, we construct an actively secured protocol from a passively secured one. So under our settings, we construct two efficient protocols with passive security. Let's discuss the flow diagram for our project. An initiator creates a repository for the users. Once they log in, they can set up the security parameters by creating a public key and private key using Diffie-Hellman process and encrypt the key. And once they encrypt the key, they can pass it to the user. The user can create a repository and log in and decrypt the public key. And once there is an interaction happens between them. So the security construction provides a passive and active connection using the group key agreement. So the lower bound, finally we are finding the lower bound efficiency using a graph evaluation. Let's see the execution process. First we are creating a repository for a particular group, that is particular user. So he has to mention the group name, and he has given the name and email ID and password and submitting the details. So after submitting, the user can log into their account using the credentials. So here I am logging using the credentials, my ID and password. So I'm going to sign in into my account. So I'm logging successfully. Here I am creating a private key. First the user will create a private key and save the private key. We can view the private key here. So after creating this, the admin, that is the key generator, will use that particular user ID to log into their account and generate some private and public key. So here the admin has logged in. He has several options will be given. So to find the security parameter, he has generating a private key and a public key. The admin will save the key and we can view the key. So this is the public key and the private key. So after this, coming to the user interaction, the user want to get the public key. He click the public key and we can get the public key and encrypt the key. Now I am loading the key and send it to the user. The user will get a message. Select the path to receive the encrypted key, and the user has to decrypt the key to use it. So the user is selecting the path and starting the server. So the key has been loaded and the key has been sent. So I'm loading the key and sending it to the user. Now the key is received to the user. The user can send and receive messages now by using some session keys. So this is the session key. I'm encrypting the message and share the session key to the other user and send a message. Now on the other hand, the another user will see the message using the key. That means the key which we shared. So this is using the shared key, they can view the message. Now the message is in encrypted format. To decrypt it, the user has to use the signature value. The signature is the session key which is shared. So after this, the message has been decrypted. Likewise, he can reply again to the user by encrypting the message. So here once again the other user can get the message and decrypt it. Likewise, it will go on by using this group key. That is, there is a key agreement between the users and the key manager. So next thing is we are going to see the passive secure construction. Passive secure construction is how the session key has made. This is the session information and this is the session identifier. Session information list and the session identifier, that is group key which was created. So here we are calculating the complexity, computation cost and route complexity, everything. So I'm going to evaluate this. So before evaluating this, we can also check for the partial root key. Using the secret key we can check the partial root key. This is the partial group key. The partial group key is used when the user wants to interact with other user. That's it. That is, using the partial group key, yes, they can see the partial group key. So now I am evaluating the process. By using the graph, we can see the efficiency which has been produced by using those partial group keys agreement. Thank you.